As we are doing our calculating our molar mass of a compound. That's what we're going to focus on today. Now, everyone should have a handy dandy periodic table next to them. And I should remember that whenever I have the mole of something, whether that mole be of gold, krypton, iron, or calcium, my mole always equals 6.022 times 10 to the 23 atoms of that material. I should also know that if I were to weigh out those atoms or that mole, they would give me the molar mass of the element in grams. So if I was looking at number 1 mole of gold, and I was trying to figure out, hey, what's 1 mole of gold worth? I pull up my periodic table, try to get the glare out the way. I see that gold has a molar mass of 196.97. So that means that 1 mole of gold would weigh out 196.97 grams gold. I know that if I take a look at my periodic table for calcium I see has the molar mass of 40.08. 40.08 grams of calcium. My molar mass of the element in grams is going to equal 6.022 times 10 to the 23 atoms of calcium. If I were to weigh out all those atoms, I would get 40.08 grams of calcium. If I look at krypton, if I weigh out 83.80 grams of krypton I find over here, in my noble gas, I find it 84.80 grams is equal to how many moles? 1 mole of krypton. Number 4 was going to require you to do a little bit of math. Now, as you may have figured out, Mr. Wiseman has a huge affinity to the metal iron because it's just so dang cool. It can get to an oxidation state or charge state of a +1 all the way to a +6. Sir?
The third question, which is how many moles were in that amount of krypton?
Right.
It says 84.80 is the weight of krypton. So
Did I write it wrong?
It says 84.80 on the periodic table.
I apologize. That should have been 84. I made a mistake. I apologize.
Do you have Katie?
Katie who?
Remember from it?
Katie? Sure. Is it a good borrow or a bad borrow?
Great borrow.
Oh, even better. But let's say I got a certain amount of atoms. Now I know that 1 mole of iron should only hold 6.022 times 10 to the 23 atoms. But I got 3.7 times 10 to the 30 atoms. And I want to find out how many grams of iron I have. So, I need to do a little bit of math. First thing I need to do, when I'm doing my dimensional analysis, I have 3 steps. My first step is I need to write out all my equalities. Now, the nice thing about this is that all my equalities are pretty much right here. 1 mole of iron is equal to 6.022 times 10, 23 atoms of iron. And that also equals out to, if I look at my periodic table, iron's number 26 on my periodic table. I see, if I get past the glare, there we go, 55.85. So it's 5.85 grams of iron. Part 2. Number 2, I need to rewrite my question. So, my question is 3.7 times 10 to 30 atoms of iron. Now, to make life easier, I'm just going to take this number. I'm going to just put it into a fraction. Anything divided by 1 is that thing. So, to make life easier, when I start talking about numerators and denominators, I just make everything have a numerator and a denominator. At step 3, I'm going to multiply using my dimensional analysis. Now, I have atoms. I want to get to grams. So am I going to use the mole or am I just going to use grams? I don't need moles, right? I have atoms. I need it in grams, right? So my question to you, how am I going to write my next fraction? I want grams. Am I going to write it as option number 1? 6.022 times 10 to the 23 atoms over 55.85 grams, or option 2, I'm going to have the grams in my numerator. Which fraction do you think I'm going to use? Show me a finger. Not your middle one. Am I going to use fraction number 1 to multiply my dimensional analysis question, or will I use option number 2? Raise them high so I can see them, gang. I'm sitting down. It's hard for me to see. If I don't see fingers, I start calling on people. Like Jasmine, which one are you choosing? Nice choice, Jasmine. Jackie, which one are you choosing? 1 or 2? There you go. There we go. Perla, which one are you choosing? 1 or 2? There we go. All right, we're choosing number 2. Number 2 is the correct choice. Why? Because whatever I want has to be in the numerator. I want grams. Grams has to be in the numerator. 55.85 grams iron divided by 6.022 times 10 to the 23 atoms of iron. Now, this is what I'm going to need to get a little piece of paper here because I'm running out of space. Ka-chow. Ask and thou shalt receive. Let's slide this up a little bit. There we go. There we go. I need a calculator too. So, on my handy-dandy calculator, if I remember my rules about Algebra 1 rules, is that when I'm multiplying fractions, I multiply all the numerators together, I multiply all the denominators together. Cool thing about that is that if I have something in my numerator and my denominator, they're going to cancel each other out. That's why I always want whatever I want to keep in my numerator. It's very important that what I want is in the numerator. Don't get them twisted. So let's do a little bit of math. So I got 3.7 times 10 to the 30. Now, to remember how we do that, we got to hit the little yellow second key. And then we're going to press this button right here, the double E button. That's going to give me, oh, if I can do things right, 3.7, Shift E. There we go. That's going to give me my E function. Remember, my E function is my times 10 to whatever number I put behind it. So if I have 3.7 times 10 to the 30, multiply that by my numerator, 55.85. I hit enter. I'm not done yet because now I got to make sure I divide by my 1 times 6.022 times 10 to the 23 atoms. So I click the divide button, takes my answer, throws it right there for me. 6.022 second E 23 I hit enter, and I get this wild number. I get 343,150,116.2 grams. Is that my final answer? What do I gotta do? Gotta round it, right? How many sig figs am I gonna use? 1, 2, 3, 4. How many sig figs my final answer gotta have? 2. Because I count them 1, 2. I have 2 sig figs in my question. Therefore, I can only have 2 sig figs in my final answer. If I do that, come down here. 1, 2. Draw my rounding line. Is that going to stay 34 or is it going to bump up to 35? Stay 34. 3, 4. What am I going to do about all of this right here? So I just cut off and say 34 grams? No. I got to put some zeros in there. That's my placeholders, right? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7 grams. Or I can rewrite that as 3.4 times 10. 1, 2, 3, 4, 5, 6, 7, 8. 8 grams. Either one would be an appropriate answer. Be mindful that notice that I only counted to the decimal. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. If I put the decimal in and put a 0 for that 10th place, I went from 2 sig figs to 1, 2, 3, 4, 5, 6, 7, 8 sig figs at that point. Remember, my tailing zeros do not count unless there's a decimal place there. So we can leave it just like that. Either one would be the right answer. When you come to the quiz, because we're going to have a quiz on this next week, what I'm expecting to see, I'm expecting to see that you wrote down your equalities. Number 1, we write down the equalities. Number 2, you rewrote the question. And number 3, you showed me the math using your dimensional analysis. 1, 2, 3, answer. Next week, next Wednesday, you will have a quiz. There are 4 questions on said quiz. It is worth 40 points. If you are not accustomed to putting your units in your fractions, you need to start. Because that's an easy point that you're losing. Easy. If it was this one, 1, 2, 3 points you would have lost out of the 10 points you could have gained from that question. That's great that you put 3.7 times 10 to the 30 as when you rewrote the question. But what does that number mean? Dogs, cats, potato chips. Without the unit, the number's meaningless. You got to make sure you carry them. Because when you're doing this, you can see whatever's up top has to be on the bottom of my next one. What's the numerator in my first fraction has to be in the denominator of my second fraction. How I make sure that I'm doing that? I put the units there. I cross them out. I work my way through my problem. I know which units I have to end up with. Make sure they're there. They're an easy point to lose, but an important point to gain. All right. Anyone have any questions on the warm-up? Questions going once, going twice. So to the sleeping ones in the back. So let's take a look at the homework. Now, unfortunately, I left my answer key at home because Mr. Wiseman also sometimes leaves his work at home. Sad. So I want to focus on the 3 final questions. Number 6, number 7, and number 8. Because there was a question I had in my first period going, Mr. Wiseman, when should we use the dimensional analysis? Use those equalities? And the answer is all the time. Every time you are offered, every time that you are asked about dimensional analysis question, you should write it out. Now on the warm-up, did I write out the dimensional analysis for these 3? Technically I did. I put it all right here. All my information I need. 1 mole of whatever I was looking at equals 6.022 times 10 to the 23 atoms. And that's equal to the molar mass of whatever the element is in grams. By having that there, I can't go wrong. If I'm looking at question number 6, how many atoms of magnesium are in 53 moles? 58.0 moles. First thing I always want to do is I always want to write out my equalities. Step 1, always equalities. So I know 1 mole of magnesium holds 6.022 times 10 to the 23 atoms of magnesium. Always, every day, never changes. What does change is how much material I have to weigh to get to that 6.022 times 10 to the 23 atoms. Remember, my 6.022 times 10 to the 23 atoms, is my dozen. It is my dozen in chemistry. Whether I'm looking at a dozen donuts, a dozen paper clips, a dozen students, a dozen binders, the amount of what I'm looking at never changes. It's always 12. 12 donuts, 12 paper clips, 12 students, 12 binders. What does change is if I weigh them out. Would a dozen students weigh more than a dozen donuts? I'd hope so. Would a dozen paper clips weigh more than a dozen donuts? Probably not. The grams will change. The mole and the amount of atoms will not. Sir. Yeah, you got it. Should be over there, I think. So, if I look at my periodic table, I see my molar mass for magnesium is 24.31. So we have equals 24.31 grams magnesium. I have all the equalities I could possibly need. I rewrite my question. I have 58.0 moles. And I want to figure out how many atoms there are. So I turn this into a fraction real quick. So I know I need moles. Am I going to use the atoms or am I going to use the grams? Which one am I going to use? Which one am I looking for? Am I looking for atoms or grams? Looking for atoms, right? So, if moles is in the numerator of my first fraction, what has to be in my denominator of my next fraction? Moles is up here. What's going down here? Moles again. 1 mole. And that's equal to my 6.022 times 10 to the 23 atoms of magnesium. My moles cancel each other out. Pull up my handy dandy calculator. Turn it on again. 58.0 times 6.022. Second button. E. 23. It's going to give me a total of, find a spot where it's not in the glare. There we go. 3.49276 E25. Am I done with that number? What am I doing to it? What do I got to do to it now? What am I doing to the number, guys? Starts with an R. Got to round it. How many sig figs can my final answer have? 3, because my question only has 3. 1, 2, 3. Does it stay 3.49 or do I bump it up to a 3.50? 3.49. 3.49 times 10, 25 atoms magnesium. Step 1, step 2, step 3, answer. Number 7. What is the mass in grams of 5.60 times 10 to the 28 atoms of copper? So, I know 1 mole of copper equals 6.022 times 10 to the 23 atoms of copper. How much? If I was to weigh out that many atoms, how much copper am I going to weigh out? Someone shout out what it is in grams. What's your periodic table tell you? 63.55 grams copper. So, part 1, I wrote my qualities. Part 2, I rewrite my question. My question is 5.60 times 10 to the 28 atoms Cu. Turn that into a fraction. So, I have atoms. Am I going for moles or grams? Grams. So what should be in my numerator? 63.55 grams copper. Atoms over here. Atoms has to be on the bottom. 6.022 times 10, 23 atoms Cu. Notice that I'm carrying those units with it, right? You want to make sure you have those units because you're going to get lost sometimes. You want to make sure you know what you're doing. So, 5.60, shift second E, 28 times 63.55 grams. Gives me this number, but I'm not done. I'm then going to divide it by my 6.022 times 10 to 23 atoms. So, shift answer divided by 6.022 23. Let me check that real fast. 5.60 shift E 28 times 63.55 divided by 6.022 shift E 23. Oh, that was right. So I'm going to get a total of 5909664.563 grams. Is that my final answer? No. How many sig figs is my final answer going to have? 3. 591, 1, 2, 3, 4. 1, 2, 3, 4 grams, or we could rewrite that as 5.91, 1, 2, 3, 4, 5, 6, times 10 to the power of 6 grams copper. Either one would be a proper answer. Either you left the zeros there, that's fine. You're not getting points off because you didn't put it in scientific notation. I just get tired of writing zeros. If right here is where you feel comfortable at stopping, you stop there. You don't have to give me the scientific notation of that number. You gave me the equalities. You gave me the dimensional analysis equation. You gave me your answer rounded to the proper place. You could stop right there and you'd be perfect. If you feel comfortable, that's only if you feel comfortable, you can put it into the scientific notation. You do not have to get this one. You have to give me this. You have to give me the fractions. You have to give me your rounded answer. If you stop there, you are fine. You are golden. If you feel comfortable putting in the scientific notation, go for it. Lastly, how many moles do we have in 78.0 grams of lead? So 1 mole of lead equals 6.022 times 10 to 23 atoms of lead is equal to, if I look at the weight of it, 207.2 grams lead. Excuse me. So, step 1, I rewrite out my qualities. Step 2, I write out my question again, rewrite my question. 76.0 grams lead. Turn down to a quick fraction so I don't have to worry about it. So I want moles. What am I putting in my denominator? Am I putting the atoms or am I putting the grams? Grams. 207.2 grams lead. Grams lead cancel each other out. Technically, my ones also would cancel each other out. So I just have 76.0 divided by 207.2. Gives me a pretty long number, 0.36679536668 moles. Is that my final answer? How many sig figs am I going to have in my final answer? 3. 1, 2, 3. 0.37 moles lead. If you are not feeling comfortable with this level of dimensional analysis, you need to come to me during your next period. You need to stay after school with me. I'm under the assumption that you can do dimensional analysis fairly confidently. If you cannot, that means we got to work at it. That means we got to work at it on your time. This is the extent of what you get in class. We go over a couple questions. If you're struggling on it now, I promise you're going to be struggling on it next week when you take the quiz on it. You struggle on it next week, you're going to be failing the test that you're going to take the following week. And that test will go in on this quarter. Set yourself up for success. All right. Let's jump into what we're doing today. Before we get started, I need you to grab two things. Two things. I need you to come over here. You need to grab. One, you need to make sure you have a calculator where you're at. Also, periodic table. Also, you want to make sure you grab molar mass worksheet. You need this sheet. You also need the homework, the mole problems. You're going to do questions 1 through 10 tonight for homework on this piece of paper. This is the one we're going to take notes on and do stuff with. Everyone come grab one. And we'll talk about what we picked up last time. All right. Okay, all right. Be mindful of what you're grabbing, John. You've already got the mole sheet. You just need the two that are over there. Molar mass and the mole problems. Ma'am. Yes. Mole questions, mole problems. So, last time in class, you should have picked up, we could use our periodic table to tell how many grams are in 1 mole of an element. And I can pull that directly from the periodic table on your little sheet. If I'm looking at carbon, I see two numbers on carbon. I see the number 6 at the top. That's my atomic number. That tells me how many protons are in the nucleus of my atom. And I see this lower number at the bottom of my screen. That is my molar mass. If ever I'm confused at how many grams are in 1 mole, I literally have it right here on my periodic table. If I would weigh out 1 mole of carbon, it will weigh up to 12.01 grams. And like our surprise cat here, 1 mole of carbon equals my 12.01 grams of carbon. Mine's a little bit more precise because I stole it from the internet. But 1 mole of carbon will equal your molar mass in grams. If I wanted to look at hydrogen, if I was looking at 1 mole hydrogen, that's equal to 1.01 grams hydrogen. If I was looking at, we use a non-metal, let's look at titanium. 1 mole, number 22 on the periodic table, titanium is equal to 47.87 grams titanium. No matter what element I'm looking at, that second number tells me how much that mole weighs in grams. Everything I need is right here on this periodic table. Now, you might have come to the conclusion that the majority of things that we look at in chemistry are not just the elements. We also look at a lot of combinations. We look at ionic compounds, we look at covalent compounds, we look at acids, maybe we'll get to bases, but a lot of these things have multiple atoms hanging out with each other. How can I calculate the mass of these items? We are just going to add all of them together. Because we mostly deal with compounds, we need to be able to calculate the molar mass of a compound. And what we see at the top of the worksheet that we're going to work on today, the molar mass of a compound is equal to the sum of all the atomic masses in the formula. All the atomic masses of the elements. So on your handout, you have an example of calcium chloride. How many calcium atoms do you have in this compound of calcium chloride? Do you have 1 calcium, 2, 3, 4? How many calciums do I have right here? 1. I only have 1 calcium. How many chlorines do I have in my calcium chloride? 2, right? Watch this. If I take a look at my periodic table, we said we have 1 calcium, right? I'm looking for the sum. What sum mean? Just means addition. In parentheses, I have 1 times my molar mass of calcium, which is 40.08. 40.08 grams. That's my calcium. Plus, I have 2 atoms of chlorine. 2 times, flip it over to chlorine. Chlorine is 35.45 grams. 35.45 grams chlorine. And I have 2 of those. I pull up my handy-dandy calculator. In parentheses, I have 1 times 40.08 grams plus 2 times 35.45 grams of chlorine means I have a total of 110.98 grams of calcium chloride. Meaning 1 mole of calcium chloride is equal to 110.98 6.98 grams calcium chloride. How many atoms will I find in 110.98 grams of calcium chloride? How many moles of calcium chloride do I have? Only have one, right? What's my number? If I have 1 mole of something, how many atoms do I have of it? 6.022 times 10 to 23 atoms of calcium chloride. My mole always equals 6.022 times 10 to the 23 atoms. It is my dozen. Whether I'm looking at a dozen paper clips, a dozen donuts, a dozen students, a dozen binders, it always means 12 of something. 12 donuts, 12 paper clips, 12 students, 12 binders. 1 mole always equals 6.022 times 10 to the 23 atoms. This is our dozen. What changes is how much I weigh out. A student typically, 12 students would typically weigh more than 12 donuts. 12 donuts would typically weigh more than 12 paper clips. 12 binders typically are going to weigh less than 12 students. Mole, atoms, always are the same. 1 mole always equals 6.022 times 10 to the 23 atoms. It's the grams that's going to change. I want you to use your whiteboards on this one. On your whiteboards, I want you to determine the molar mass of sulfur dioxide. I'm going to give you 3 minutes to work on it. Once I can get a when the music stops, we'll check it. So, everybody needs their whiteboards. Everybody needs to be working on that question. Yep. Oh, you see that? So at the time when I put the rate in, it had to be great. So we checked to make sure. And I thought I updated it for stuff that I graded. But I have another test still, so I will check it. It's very well. I just forgot to put it up. All right? All right, we got 42 seconds, guys. Then we'll have you show me your boards. I want to see your work. Don't just tell me how many grams there are. I want to visibly see what you did. Alright. So, show me your whiteboards, everybody. And a 3, a 2, a 1. Let me see what you did. All right, I got some good work. Good work. Sandy, what you got so far? Very nice. Jackie, what you got so far? Jackie, what you got so far, girl? Zoe, what you did? Show me your whiteboard, girl. Everyone else got to show me the whiteboard. That means you got to show me yours, too. All right. All right, all right, all right. All right, all right. So I saw some good work out there, ladies and gentlemen. Positive work out there. Positive work. So, how many sulfur ions do I have here in my compound? How many sulfur atoms do I have? Sulfur, how many do I have? One of them. How many oxygens do I have? Two of them. All right, so I got my periodic table. Sulfur is over here. 30, oh, can't see it. 32.07. So 1 times 32.07 grams plus, I have 2 oxygens. And if I take a look at my periodic table, I will see if I can get past the glare. 16.00. 16.00 grams. Now, to be fair, do I need to put the 1 times 32.07? There's only one sulfur. I would recommend that you do it. Because what it is, it's a process. I'm making sure I'm accounting I only have 1 sulfur. Right? And I had two oxygens. Yes, it gets a little annoying in the beginning, but it's going to make sure that you're doing your math right. 1 times 32.07, close my parentheses, plus 2 times 16.00, close my parentheses, gives me a total of 64.07 grams SO2. So, like I said, got some good work out there, good work out there. On the back of your packet, I want to go through this one. Let's do an example with parentheses. The first one we're going to walk through together. The second one you're going to do by yourself. So I still want to determine the molar mass of my compound calcium nitrate. Now, if I remember from my nomenclature, I know nitrate has a -1 charge. So to cancel out my charges, I needed 2 nitrate ions. That's how I get the CaNO3 2. How many calcium atoms do I have in this formula? How many calcium ions? 1. How many nitrogens do I have? 2. Good catch. Because my parentheses, everything in here is times 2. 2 times 1 is 2. How many oxygens do I have? Not 3. You're close. 2 times 3 equals what? 6. 2 times 3. That's all right. That's all right. They're close. I can see the mistake happen. So, when I'm calculating the molar mass, I got to do it for everybody. So, pull up my handy dandy. I should, at this point, I already know that calcium has a molar mass of 40.08 grams because I've been doing it over and over and over again. Nitrogen, 2 times, remember correctly, that's 14.01. Nitrogen, 14.01. 14.01 grams plus 6 oxygens. I had 139 atoms. 139 atoms. I accounted for everything. 1 times 40.08 plus 2 times 14.01 plus 6 times 16. I'm going to get a grand total of 1 mole of calcium nitrate equals 164.1 grams. 164.1 grams CaNO3 How many atoms does that equal? How many atoms, guys, is in 1 mole? There you go. 6.022 times 10 to 23 atoms. CaCl. Ca, calcium nitrate. Whatever I have 1 mole of, I have this many. The mole is my dozen. Avogadro's number is my 12. 1 mole of anything always equals 6.022 times 10 to the 23 atoms. To get 1 mole of calcium nitrate, I got to weigh out 164.1 grams of calcium nitrate. These 3 items are tied together. That's why when we do the equalities, I write all 3 of them out. You may not need to use all 3 for a question, but you do need to know 1 mole not only equals the grams, but 1 mole also equals this amount of atoms. Ma'am.
Is that a big unit for speaking?
Yep.
Okay.
Yep. This one is an example. I said flip your paper, take your sheets up, flip it over. We're walking through one because now you're going to do one by yourself. And the next one, we're actually going to do some of the questions on the handout that you got. Right now, we're building up our experience before we get to those 6 questions in front of us. I have on your whiteboards, I have given you strontium hydroxide. On your whiteboards, you're going to calculate you're going to calculate the mass, the molar mass of strontium hydroxide. 3 minutes. Your time starts now. On your whiteboards, ladies and gentlemen, on your whiteboards. Whew. That's on weight. You're absolutely on the right track. That's awesome. Yes. Tests are graded. You never get the test back. Quizzes you get back, but the tests never get back.
Why is it?
Chemistry rules. We tend to read some stuff every once in a while. So instead of having to rewrite a test every time, we can just hold on to the information. And then we don't have to worry about someone just having an extra test that's floating around. Same thing. Well, Shannon right now is on the path, when she comes back, she can grab it. So, you multiply your oxygen by 2 and your hydrogen by 2, and then you add all those values together. All right, ladies and gentlemen, let's go ahead and walk our way through it. Well, first I want to see what your whiteboards look like. What do your whiteboards look like, ladies and gentlemen? Show them in 3, 2, 1. Let's see what you got. Let's see how far you got. Jasmine, where's your whiteboard at, Jasmine? Thank you, ladies. Thank you, ladies. Thank you, ladies. Boom, boom, boom. Thank you, thank you, thank you, thank you. Thank you. Thank you, Abigail. Dakota, you were out. So let me see what you got so far. Looking good, looking good. Jackie, let me see what you did. Sandy, let me see what you did. All right, all right. Perfect, perfect. Looking good. All right, all right, all right, all right. All right, all right. So, pull out my handy dandy periodic table, look for strontium. Bam, I find that 82.67. I only have one of those. So, 1 times 87.62 grams plus, I have 2 oxygens because my parentheses out here. 2 times 1 is 2. 2 times 1, so I have 2 oxygens, 2 hydrogens. I have to account for that. 2 times oxygen was 16 plus 2 times 1.01 grams for my hydrogen. Pull out my handy dandy calculator. Bop, bop, bop. Parentheses 1 times 87.62. Close it. Plus 2 times 16 plus 2 times 1.01 equals 121.64 grams. That's how many grams I have of strontium hydroxide. That equals 1 mole strontium hydroxide. That equals 6.022 times 10 to the 23 atoms of strontium hydroxide. Excuse me. So I saw some good work out there. Good work, good work. I want you to take a look at questions on the handout. I want you to try to take a stab at answering number 1 by yourself. We'll do the 3 minutes. When the music stops, that's what I'm going to ask. That's when we're going to walk through it. Just worry about writing it on your paper right now. Don't worry about the whiteboard at the moment. I want you to write it down on your paper. Ooh, ow, 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 ow. Did I put in attendance today? Anybody in here ride bus 17? No? All right, then you don't need to worry about the bus changes then. It's the only bus change. All right. Far out, my dude. Far out. Far out. Ow! That hurt. All right, ladies and gentlemen. All right. So let's look at number one together real quick. So I have one aluminum. Looking at aluminum fluoride. How many fluorine ions do I have? How many fluorines do we have in aluminum fluoride? 3 of them. So 1 times, taking a look at my aluminum. Aluminum gives me a molar mass of 26.98. 26.98 grams. Gentlemen, calm down a little bit. There's 3 fluorine atoms. So we look at a molecular weight of that is 19 even. 19.00 grams. So I do a little quick math. Pull out my calculator. Parentheses. 1 times 26.98, close parentheses, plus 3 times 19.00, why not, equals 83.98 grams for aluminum fluoride, which also equals 1 mole of aluminum fluoride. We got 10 minutes left in class for the bell rings. I want you to try to do number 3 and number 6 by yourselves. I want you to do number 3 and number 6 by yourselves. I'm going to give you 5 minutes for those. At the end of the music, we're going to take a look at both of them together. Your homework tonight. Make sure when you get a chance, make sure you have a chance to write in your planners. Questions 1 through 10 on this sheet, the mold problems. I only want you to do questions 1 through 10. I will give you a warning for number 9. I'm going to ask you to determine the volume in liters of 4.7 moles of sulfur dioxide at STP, standard temperature and pressure. Very top of your page, it gives you the conversion from 1 mole to 22.4 liters of STP, standard temperature and pressure. So, you're going to use that conversion to help you answer number 9 for sure. Out of the 10 questions that you're going to answer, make sure you walk out with this piece of paper. Training game, you have this one? Okay. Let's see you packing up. We'll make sure you got everything you need. I want you 3, I want you 6. All right, ladies and gentlemen, let's take a look. So right here are my 2 answers. So in order to answer number 3, I first had to come up with the formula, which we should be good at because that was the last unit we just did. Chromium 2 selenide, so that means I have Cr2 plus 2. Selenium gives me a -2 charge. My charges cancel each other out, so I have 1 chromium, 1 selenium atom, 1 times 51.99 grams for my chromium, plus 78.97 for my selenium, gives me 130.96 grams of my compound. We should be able to do that. Where we lost that, ladies? I see some faces. A little bit more. There we go. Try to zoom in a little bit more. That's my chromium. That's my selenium. I add them together. I get 130.96 grams CRSE. I had to first come up with the formula to figure out how many atoms I had in my compound. Lastly, number 6, I had the parentheses, right? So I had to first distribute that 2 to everything in the parentheses. 2 times 1 nitrogen means I have 2 nitrogens. 2 times 4 hydrogens means I have 8 hydrogens altogether. 1 sulfur, 4 oxygens. To make it easier for you, I also put the element above the math to help you see which one was which. I add everything together. The molar mass of ammonium sulfate is 132.17 grams, which equals my mole, which equals 6.022 times 10 to the 23 atoms of ammonium sulfate. Your homework for this evening is to rock out those 4 questions. Sorry, those 10 questions on your mole problem sheet. Again, I'll warn you. If you're given the gas, it's something at STP at the very top of your sheet. I'm confiscating John's paper real fast. I'm going to hand it back to you, John. At the very top, it tells you the conversion rate. Moles per gram is equal to 27.4 liters gas. STP. Be mindful of it. All you gotta do is questions 1 through 10. We'll do the other ones later, but let's first make sure we understand questions 1 through 10 first. And ladies and gentlemen, that is it for us today.